This is 8.1.1. Rutherford's alpha scattering. Now, prior to the nuclear model of the atom, there was the plum pudding model, which was given by J.J. Thomson. And the plum pudding model had the atom as one large body of positive charge with smaller negative charges embedded within it. So this was given to us by J.J. Thomson. So you had a large positive blob with small negative charges randomly dispersed. So the atom was still neutral in this case, but the model was different. So Rutherford did an experiment. Now, they knew that alpha particles were positively charged. And what he did is he had a source of alpha radiation. He had this source collimated so that it produced a beam of alpha particles rather than emitting alpha particles in random directions. These alpha particles then went for a gold foil. We use gold foil because gold is soft, so it can be rolled very, very thin, so that it's only about just an atom or a couple of atoms thick. Now, under normal circumstances, if J.J. Thomson's model had been correct, each of these blobs are neutral. So if each of these atoms are neutral, then all of the alpha particles should have just passed straight through because they would not interact with it. In reality, what happened is most passed straight through, but some alpha particles were either deflected to some angle or deflected in a way where they came back towards the emitter. The ones that got through, or even the ones that deflected, to detect those alpha particles, you need to put some kind of detection device around it. So the most simple way of doing it is to basically put a large curved screen, a fluorescent screen, so when the alpha particles strike the screen, you can see it fluoresce. Other ways of doing it is to put multiple screens around, equidistant from the gold foil, or you could put, for example, a GM tube, and you'd have to move that around. So the best way is to have a large curved screen. So let's sketch his experiment. So we've got an alpha source. And in brackets, I'm going to put collimated. So the collimator essentially is just basically like a tube. So if you place an alpha source in a long tube, in fact, it doesn't have to be very long. If you place it in a tube with all ends closed except for one end, which is open, alpha particles that are being emitted in random directions are blocked by that tube. And only alpha particles which go straight will pass through the opening of the tube. So if it's at some angle, by the time it gets towards the opening of the tube, it would actually strike the edges of the tube. So it's been collimated. That turns it into a beam of alpha particles rather than alpha particles moving in random directions. Then we have our screen, which surrounds this apparatus. So here I'll label this as the fluorescent screen. and we'll put a gold foil here. Now, sketching our alpha particles. So these are alpha particles. So most of them passed straight through. Some of them had deflections, and some of them even came back.